Welcome to another edition of QHSV Concepts Welding and NDT channel. Today I am bringing you the presentation on valves, piping valves. We have used we use a lot of industrial valves in the oil and gas sector. So valves are very, very important components in any piping system. So any QC inspector who is taking up CSWIP 3.1 ultimately going to become welding inspector, but also doing welding inspection. Then another part of the job is to do the piping inspection. So piping inspection, you can take up other courses like API 570, and so many courses are there for piping, but naturally you will have to learn these individual items. So this presentation will go a long way to help you in understanding those things. So let's proceed in this presentation. See a lot of valves related information in this. So valves are mechanical devices specifically designed to direct, start, stop, and mix or regulate the flow, pressure, and temperature of the process fluid. Why we call it process fluid? Because in oil and gas or in any kind of industry, pharma or anywhere, you will see that the liquid that is being either transported or is either going to become a product is called as process fluid. So in 1681, the first safety valve was invented by Dennis Papin. And this information is very, historically important. So by 1840s, so in 16th century, we already know that in Europe, Renaissance was happening and a lot of developments were happening scientifically and all that. So those days, all inventions have started. So by 1840s, the first valve patent was granted in the United States, and it went to James Robinson for his great valve. So one of the first valves which came into being, gate valve, which got patented. So amongst all the various kind of valves that you will see, you have to know that gate valve got the first patent. So in 1846, the globe valve design was developed and patented by Walworth. And that's worth knowing. The Mercedes car built around 19th century introduced a butterfly valve in the fuel intake linked to the accelerator pedal. So that was a very big development. So you have an accelerator where you are going to inject fuel into the engine, and to do that, Mercedes car invented the butterfly valve, and that's how butterfly valve first came into being, or the first usage of butterfly valve came into being. So functions, as per you should know, for the valves is stopping and starting a fluid flow, and depending on whether a valve is open or closed, it passes the process fluid and halts the process fluid. Throttling the fluid flow also. Some of the valves will let you throttle the fluid depending on the percentage that they are open or closed. Depending on that, lesser the opening, higher the throttling, and other vice versa. Controlling the direction of the fluid flow, multi-port valves let you decide the way which the fluid will go. So many times the multi-port valves are used so that there will be one intake and several offtakes. Regulating a flow or pressure within the piping system. So these valves are usually regulating the flow in any piping system based on the process requirements. So some automatic control valves maintain flow and pressure within the system by adjusting opening and closing. So you must have seen many valves in the refinery or any place where you have gone. There you must have seen a lot of valves, but you can see that critical valves usually are process controlled. That means they are sitting in the operation control room, and they can decide the valve to close or open from there via software. Many of the valves are manual valves, which have to be gone to the site, and there only they have to be physically switched off or on. So in case the software, or let's say the control valves don't work, you always have a manual valve at least. So both the valves are designed in the system, and we cannot rely only on manual and only on software related process control valves these days. So pressure relieving or vacuum from piping system and equipment. Pressure and vacuum relief valves safeguard the process system from overpressure and during the vacuum condition. So ideally the valve functions not only as starting, stopping the liquid, but it is also used as a safeguard mechanism, and also to regulate the pressure, and is also during the vacuuming, if there is any vacuuming condition happening somewhere, the other side the valve can be kept a little bit open so that the vacuum will not become so hard that it will damage the whole system or piping. So what is the basic construction of valve? So you can understand valve based on their construction, body construction also. So for the body, the main pressure containing structure of the valve and contains the valve internal parts that comes in contact with working fluid. So that is how what the body's function is. Then there is on top of the valve, you will always see a bonnet, typically like a bonnet of the car. It is always on the top of it. So it provides a leak-proof closure for the valve body. So between the valve body and the closure mechanism, which is either be a disc or a handle, you will see a bonnet which is actually housing these kind of things with a seal, and it is leak proof so that it will provide the valve opening and closing easily without any leakage. Then basic construction also, seat ring, you can differentiate a valve by seat ring also. Seat rings, what they do, they provide uniform leak proof tightness, usually beveled to allow guiding during the final stage of closure. So depending on the waffle or the gate, whichever is going to close the valve, these rings are also having taper. You can see in this photo, its tapering is available there. So also the disc valves are also classified as per the discs. So what functions the disc is? The disc is a closure member of the valve, rest on the seat ring and connected to the stem, which slide or screw up or down the throttle using the handle. So that's what the function of the baffle is. In this case, we are showing you a check valve. So this is like a non-return valve. The fluid will pass from one direction, and the other side you will see that the fluid, if it tries to go back, this baffle will close and it will not allow the fluid to go to the other side. So let's see at the stem. You can see any valve, the closure mechanism is by a stem, because the operation of the baffle or any gate is this stem is important for operating it. So connect actuators handles to the inside of the valve disc and transmits the actuation force. Stem are either smooth or actuated control valves or threaded or manual valves. So that you need to know very precisely. Let's see the classification of valves based on end connections. You can have end connections also can become different. There were like beveled end, there is screwed end, there is a flanged end. So based on end connection, valves can either be screwed or threaded that connects with matching thread on the pipe. Small bore valve used in instrument connection or sample point has a threaded end. Majority valve used in piping has flange type ends because in the piping mechanism, flange type allows bolting, and bolting you can remove the bolt anytime for shutdown during maintenance, or if you want to change the flange, easy. Then welded type or threaded also can be changed easily. Mostly flanged type is used because you cannot guarantee the threaded type will not leak during the operation. Also, butt welded valves are used in very high pressure and high temperature service. So in high temperature service, we are seeing that the threaded valves are not used. Rather, they are using welded type because it gives complete guarantee because of the temperature and pressure range. The need to withstand that pressure. Socket welded valves are also used in low pressure systems. So you might have seen many socket welded valves. These are usually low pressure system. Many times you can see socket welded valves are also used in housing also buildings. Check valve, butterfly valves are available in wafer and lug end construction. These type of ends are used when space is having a constraint. So it's also because of the process requirement, basically, whether check valve or butterfly valve will be used. So classification of valves, function, type, port type, then design, method of control, actuation. So these are all various classification of valves, which you need to remember. Valve categorized by function. So on or off isolation valve, function of blocking the flow or allowing it to pass. On return valve, so functioning of allowing the flow of travel in one direction only. And throttling, so regulation valve, so which is a function of allowing flow at any point of time between fully open to fully closed. So you can see this sort of organogram for the valves. Based on functions, you have so many type of valves. I have made this presentation has made a proper isolation, or let's say segregation. So based on functions, isolation, gate valve, ball valve, plug valve, piston valve, diaphragm valve, butterfly valve, and pinch valve. So you need to remember that isolation. If anybody says the isolation valve, then he's talking about these kind of valves. Then the regulation, that is flow regulation valve, is globe valve, needle valve, butterfly valve, diaphragm valve. So you can see diaphragm valve will do isolation also, and it will do regulation also. That you need to know. So ball valve is also having dual purpose. Here the globe valve is having unique function of regulation. So globe valve is not doing an isolation. It is doing regulation. So ball valve, plug valve, and pinch valve. So pinch valve is also having dual purpose. What about safety relief valve? So pressure safety relief valve and vacuum relief valve are the two type of relief valves you will see in the processes. And also non-return valve. Non-return valve, swing check valve, lift check valve, both types of check valves are there. They are called as NRV or non-return valve. And then there are special purpose valves built for multi-port valve, float valve, foot valve, knife gate valve, and line blind valve. So for doing blind, they're also using the line blind valve. So these are the various types of valves and their segregation. Now let's see how it is each one is constructed, and how it looks like. So valve types, valve used in the oil and gas industry or for process piping applications can be classified in multiple ways. Valve categorization by disc type. Linear, first is we will see a linear motion. So gate valve, you can see the picture of a gate valve typical. This is how a gate valve looks like, and you need to see many times gate valve also will have directions here marked by forged arrow. So gate valve is mostly used in piping and pipeline applications. So you see how the construction is. This is a typical drawing. So you can see that this is the stem which will drive the disc inside, and it will completely close the flow from both the directions. So this one is the hand wheel. The top one, you can see this is the wheel, and the wheel is having the stem which when you rotate the wheel, this will get it will either rotate or it will either go up or down. So this is locked in place by stem nut. This is the stem itself, and there is a gland flange and gland bush, and that allows no leakage from the piping valves towards the stem. It will seal the thing basically. Then there is gland packing, back seat, bolt nut, bonnet, gasket. So the bonnet houses all this and properly seals the valve. So then there is a gasket at this point of time. So there is also a back seat. You can see the yellow color. So allows that there will be no flow back charge into the handle side. So on the valve side there is this wedge which is called as a gate, and then a seat ring. This is the seat where this wedge will sit, and there is a seat ring for that. And of course this is the whole body which is in which it is housed. So globe valve is used to throttle or regulate the fluid flow. So globe valve, you can see there is a circular rounded shape in between, and that's how you will be able to identify them. So globe valve also you will have some kind of direction mark, and many times it is unidirectional, can be used either side. So you can see this is the handle, and then this is the drawing. You can see the construction where it was straight. This one is having an angular movement upwards and then downwards and on the sideways. So you can see the direction here. The direction of travel is from this side to out. Then in between you can see the disc and seat, and you can see the stem and then the bonnet where it is housed. And then the hand wheel and the hand nut. In this picture you can see this is flanged end, and whereas this is screwed or butt type. This next slide is for the check valve. Check valve is used to avoid backflow in the piping system or pipeline that could damage downstream apparatus, pumps and compressors. So you can see just like globe valve, this is also having one kind of inlet, then there is a stoppage here, and then it will let it out. You can see if you cut the check valve and see, this is how it will look. So this is the waffle, or the where it will swing when the flow is on this side, and then it will not come out. So it will allow only one direction travel of fluid. The next valve is pinch valve. Pinch valve is a linear motion valve that can be used for throttling and shutting off application in piping application, process application that handles solid materials, slurries, and dense fluids. And that's the reason why we don't see pinch valve more often used in refineries and oil processing platforms, because usually this is in land refineries you will really find this, but the application is very limited to solid materials, semi-solid liquids, slurries, and dense fluids, and that's why we don't see much use of these kind of valves. But you should know that this kind of valves are there. Then there is a diaphragm valve. You can see how clearly there is a diaphragm which, when pressed down, is able to close the flow of direction. Then there is a butterfly valve, which you remember that Mercedes-Benz used in its car in 19th century, very early 19th century. And butterfly valve is a very common found valve. It is also an actuated valve, and it can be also manually closed. So it's a very versatile, cost-effective valve to modulate or open and close the flow of the fluid. You can see this cut section of pipe, and you can see how the waffle, when you turn this stem, that just opens, like a waffle, and then it firmly sits on one location, and then it swivels from there. You can see this is the typical valve, and the arrangement is such that this is the rubber sealing, and this plate is completely properly dressed, smooth finish, and when you close it, it completely seals off the rubber, and it shuts off the water, so flow from one side to another. The next valve is ball valve, and you can see a ball valve, how it functions. It has a circular hollow section in the ball, which is encapsulated in the body. You can see this is the ball, and since it is in a circular ball shape, it's called as ball valve. So ball valve will have a handle like that, and you can simply turn it 90 degrees, and the operation will become slowly. See, this is completely shut off. This is slowly, it's opened, half valve, and this is fully closed, and this is blue one is fully open. So ball valve construction is this way, and this is also having the bonnet and the body, and it is completely housed inside you can see it's housed inside a stainless steel body here in this case, but there are also carbon steel ball valves. There is a rotary motion control. So let's see these valves. A plug valve is classified in quarter turn valve for shut-off application. Eccentric valves, swing check valve are the other kind of rotary motion. So these valves are operating using the rotary motion of the disc inside. What about quarter turn? The device that requires approximately a quarter turn motion from 0 to 90 degree of the stem to move from fully closed to fully open position, or vice versa. So in a quarter turn valve, if you turn the handle by quarter, which is 90 degree, quarter is, don't forget, 360 degree quarter is 90. So if you turn by 90 degree, that valves open or close. So valve categorized by design: piston valve, relief safety valve, needle valve, and special valve. Valves categorized by application: general service valve, severe service valve, and special service valve. Valve categorized by method and control: linear motion valve and rotary valves. Valve categorized by port size: full port valve and reduced port valve. So you have also full ports and reduced ports available in the valves. Classification of valves based on the type of actuators. So based on the actuation, there is pneumatic actuation, there is even hydraulic actuation, there is electrical actuation. So let's see the actuation. So manual, the valve operated manually by a lever, a wheel, or gear is called as manual valve, or automatic valve, which is controlled by electromechanical device called as actuator. That may be electric, pneumatic, hydraulic, and gas over oil is called as actuation valve. So based on operation, you can see manual valves can be hand wheel, hand lever, gear wheel, sometimes even chain type. But in actuation, you can have power or automatic. In power, you will have electric, pneumatic, air, hydraulic, and solenoid valves. So let's see how these valves are inspected and tested, because every inspection are going to be carried out by the inspector. So he should be knowing all the details. So when you go to the valve manufacturing facility, don't forget, not every QC inspector is getting this kind of experience and this kind of inspection chance. Many few people are getting to go into the valve manufacturer's place and do inspection. So the purchaser will specify in the purchase order his intention to inspect the valves and witness test and examination at the valves manufacturing plant. The purchaser inspector shall have free access to any part of the plant concerned with the manufacturing of the valves whenever the work on the order is underway. So what happens is when there is a large order of valve and there is a very big size of order, so the client, for example, if you say ADNOC or Saudi Aramco or any client which is a very large EPC company, or they are the field operators, they insist that since their project is big size, they would want to witness this activity. So not only they will witness, the client will witness, the end user will witness, and many times even the third party is going to do the witness. So in that case, there will be an ITP, and QC inspector will in charge of the inspection for vendor will have that ITP, and then they, along with the valve manufacturing company, will try to chalk out which stages the inspection will be done, when the RFI will be sent, and all the whole process of RFI will take place. So inspection outside the valve manufacturer's plant, when the purchaser specifies that the inspection will be including the shell component manufactured at locations other than the valve manufacturer plant, these components shall be subject to purchaser's inspection. So as you know that now, you know that the valve body, the bonnet, the disc, the rubberizing of the butterfly valve, all these activities, if it is happening in the same plant, they will witness it. Or if it is outsourced by the valve manufacturer to 2 or 3 locations, maybe they want to go there and see as well, then they can have to be prepared for that as well. So what is the extent of inspection? The extent of inspection may be specified by the manufacturer order. Usually this is in the purchase order and the contract, and then we have to make the quality plan as per that. Unless otherwise indicated, it will be limited to the following. So inspection of the valve during assembly to ensure compliance with the specification of the purchase order. Inspection may include the use of specified non-destructive methods. So they want to maybe witness the entity also. Witness, because since it is a cast valve or forced valve, they need to see the proper processes. So witness of the required and specified optional pressure test and examinations. Then witnessing on any supplementary examinations. Then review of MTC mill test record certificates and NDT records, including the radiography or UT results. Examination. A visual examination shall be performed by the valve manufacturer of all casting bodies, bonnets, covers, closure elements to assure conformance with MSSP 55. So there are many MSSP. MSSP is basically method statement standard or typical valve manufacturer. For example, SP 55. Valve manufacturer shall examine each valve to assure the compliance with standard and referenced purchase order. Example, API standard, whatever standard they have given in the purchase order, whether it is conforming to that or not. Then all examinations shall be performed in accordance with a written procedure that comply with the applicable standard. And if you place an order, purchase order for a valve which is DNV acceptance, then that DNV third party will be coming into play. If you are using this valve in marine application, then DNV marine third party will have to be called. Then if there is a PED valve, then the third party must be PED notified body. What I mean by PED valve is many times valves are made for ISO standard, and they are going to be supplied to some European company or European project. That time ISO standard requirements are there, and they are PED standards and all are involved. And that's the reason you need a notified body. Notified body is the third party, which is basically in touch with the European country notified bodies. And that's why those are the things anyway, the QC manager and QC engineer will know that, and they will write all that in the purchase order. Test equipment. So if an end clamp fixture is used, the valve manufacturer shall be able to demonstrate that the test fixture does not affect the seat sealing capability of the valve being tested. So during the hydro test or leak test of the valve, they have to ensure that the valve, while doing the test, will not undergo any kind of deformation or physical issue with the valve. So end clamp is allowed for valves designed to function between the mating flanges, such as wafer check and wafer butterfly valves. So this testing is also very important, and very experienced and knowledgeable persons are going for witnessing the hydro test. Basically, hydro test, they are making one test bench where they may put 10 valves together and test it in one go, or they may test individually. So pressure test of the valves below 4 inch and above 4 inch for below 1500 pound and then above 600 pound flange rating. You can see that the requirement for shell is required for all the things like gate valve, globe valve, plug, check, floating and butterfly valve. But back seat is applicable only for gate and globe valve and not applicable for valve types of plug, check, floating one, butterfly valve. So this you should know this. If you want, you can keep it in your office, this table, who is doing valve checking always. Low pressure closure is required only for gate valve. It's optional for globe valve. For plug valve, it is required. Again, it's optional for check valve. Again, it is required for floating ball valve and butterfly valve. Then high pressure closure test is optional for gate valve, plug valve and floating ball valve, but it is required for globe valve and for check valve also. So let's see the notes also. The back seat test is required for all valves except for below seal valves that have the back seat feature. So back seat, that is the reason, is because of the make and the construction. Not all the valves are required for the back seat to be tested. For lubricant plug valves, the high pressure closure test is mandatory, and for the low pressure closure test is optional. So lubrication, the plug valves are very important and they are supposed to be closed at high pressure. So naturally, high pressure test is required for them. When purchaser specified optional test, the test shall be performed in addition to the required test. So if he is telling it's optional, we have to always check the purchaser specification. Maybe it is required there, then you will have to do it. Then high pressure closure test of resilience seated valves may degrade subsequent sealing performance in low pressure service. So for power operated and manually operated gear actuated globe valve, including non-return globe valve, high pressure closure test shall be performed at 110% of the design pressure, a differential pressure used for sizing of the operator. Then high pressure closure test is required for all valves specified to be double block or bleed valves. So double block bleed valves and all that, high pressure is of course required. And pressure tests, again I am giving you the same chart and you can see that requirement here. So backseat test is required for all valves except for below seal valve. I think this is again repeated. For power operated, manually operated gear globe, actuated globe valve, including non-return globe valve, high pressure closure test shall be performed at 110% of the design differential pressure used for sizing of the operator. So high pressure pneumatic shell test, when specified by the purchaser or purchase order, high pressure pneumatic shell test shall be performed. This test shall be performed after the hydrostatic shell test. So you can see that they are asking along with the hydro test, air test also. So pneumatic test is required along with hydrostatic test. So that the same maximum will allow 110% of the max allowable pressure at 38 degrees or specified by the PO. Visible leakage is not allowed at all, 0. What about a test fluid? The test fluid for shell, high pressure backseat and high pressure closure test fluid shall be air, inert gas, kerosene, water or non-corrosive liquid with a viscosity not higher than that of water. So they want a liquid which is not as viscous as water unless otherwise specified in the purchase requisition. Test fluid temperature shall be 5 degrees or 250 degrees only. Why not viscous higher than water is because then the leakages are not known. If it is water and higher, it will tolerate more leakage. And in the oil and gas field, the leakage tolerance requirement is very, very less. For low pressure closure and low pressure backseat tests, test fluid shall be air or inert gas. When air or gas is used for closure, shell or back seats, the valve manufacturer shall be capable of demonstrating the adequate of the method of leakage detection. Water used for any test may contain water-soluble oil or rust inhibitors, because we are dealing with valves, and rust, we don't want to put that rust in this valves. So when specified to the purchaser, a wetting agent shall be included in the water for testing austenitic stainless steel valves. Water with chloride content not exceeding 100 ppm shall be used. The valve manufacturer shall also be able to document the chloride content. So as an inspector, you will have to ask them, if you are using water, show me the chloride content tested by independent lab, and is also what wetting agent you have used and what corrosion inhibitor you have used, whether it is compatible with. You have to send this corrosion inhibitor to your engineering and ask them to approve this before they are using it. Some test pressures I have mentioned here: cast iron, steel, all kind of flanged valves. Then shell test pressure also. So ASME V36 16.34 limits threaded end valves to 2500 and lower. And as per 16.34, for class 800 valves, the shell test pressure shall be 1.5 times the pressure rating at 38 degrees, rounded off to the next higher increment of 25 pounds per square inch gauge, or 1 bar. And see that's table 2 of API standard 6042. So it will give you this kind of requirements for test pressure. The backseat test is required for all valves that have this feature. So wherever there is backseat in the valve, it will require the backseat test. And the pressure is, as you know, 110% of the max allowable pressure at 38 degrees. Then test duration. For each type of test, the required test pressure shall be maintained for at least minimum time. As you can see, the diameter here, valve size in NPS, and the backseat feature for the shell backseat closure. This is the time duration required. So shell, stem, seal, backseat. For shell test, visually detectable leakage through the pressure boundary wall and any fixed body joint is not permitted. For backseat, visually detectable leakage is not permitted. For valves with adjustable stem seals, leakage through the stem seals during the shell test shall not be caused for rejection. However, manufacturers shall demonstrate stem seals are capable of retaining pressure at least equal to 38 degree valve rating without visible leakage. For valves with non-adjustable stem seal, O-ring, fixed seal rings, and like, visual detectable leakage during the shell test is not permitted. Where no visual detectable leakage is permitted, the following definition apply. If the test fluid is liquid, there shall be no visible evidence of drop or wetting or any external surface of the valve. So that you need to know as an inspector. If the test fluid is air or inert gas, no leakage will be revealed by established detection method. Maybe if you are using air, you have to put soap solution to find if there is any leak or not. For both low pressure closure test and high pressure closure test, the visual evidence of leakage through the disc behind the seat ring or past shaft seal is not permitted, and structural damage is not permitted. Allowable rate for leakage for test fluid at the seat sealing surface interface for the duration of the test is listed in table 5. So the allowable leakage rate for closure test for valves with non-metallic test seat material shall be equal to that of the specified in table 5 for metal seated valves of equivalent size and type. You can see the table 5 max allowable leakage rates for closure test is given 0, 0, 0, and sometimes some places it is given drops, which is allowed. Also, the notes are important. For liquid test, 1 milliliter is considered equivalent to 16 drops. There shall be no leakage for the minimum specified test duration, for that see table 4. For liquid, the earlier table. So for liquid test, 0 drop means no visible leakage per minimum specified test duration. For gas test, 0 bubble means less than 1 bubble per minimum specified test duration. So no bubbles should be seen either during the entire duration. Maximum permissible leakage rate shall be 0.18 cubic inches, which is 3 cubic centimeter per minute inches of nominal pipe size. The maximum permissible leakage shall be 0.042 cubic meter of gas hour per nominal pipe size. So these are the things which are becoming more and more stringent and is applied in oil and gas. What about the test procedures? So the pressure test procedure valve designed to permit emergency or supplemental introduction of injectable sealant to the seat area shall be tested with injection system empty and not in the use except for lubricated plug valves. So when liquid is used as the test fluid, the valve shall be essentially free from trapped air during the test. The required protective coating such as paint, which may mask the surface defect, shall not be applied to any of the surface before the inspection और प्रेशर टेस्ट. सो अगर आपको कोई पेंटिंग करके हाइड्रो टेस्ट दिखा रहा है, इसका मतलब आपको समझ जाना चाहिए कि वो आपको लीक बिल्कुल नजर नहीं आएगा. So such valves should always be tested before painting, and then after painting the test is not required to be done. So when closure testing valves, valve manufacturer test procedure shall ensure that excessive force is not used to close the valve. The applied force may be determined from the appropriate, but in any shall not exceed the values published by the valve manufacturer. So no use of any strong hand method, or to close we will use that F type handle. That is all not allowed during the test. The valve shall be visually examined for leakage after it has been fully prepared and is under full test pressure. What about the backseat test? Because we have been talking about backseat test. Backseat test is required for all the valves except for bellows and steel valves, seal valves that has at the backseat feature, and shall be performed by applying pressure inside the assembly valve with valve ends closed, the valve fully open, and the packing gland loose and the packing glands not installed. So if the backseat test is performed after the shell test, then the packing shall be installed and the packing glands retightened after the backseat test. So successful completion of this backseat test shall not be constituted as a recommendation by the valve manufacturer that while valve is pressurized, the valve stuffing box may be repackaged or packaging may be replaced. For valves in 4-inch in nominal pipe size and smaller, the backseat test may be combined with the shell test. When volumetric devices are used to monitor leakage from the shell and the back seat when tested by this method, the packing shall be loose. The manufacturer shall be responsible for demonstrating that the packing will not leak at the valve's rated pressure at 38 degrees. And let us see the shell test. Shell test is the shell test shall be made by applying the pressure inside the assembled valve with the valve end closed, the valve partially open, and any packing gland tight enough to maintain the test pressure, thereby except for the bellows seal valve testing the stuffing box. Air test. Valve shall be subjected to air test by any pressure between 5.5 to 5.9 bar gauge. In case pressure rating is less than 5.5 bar, air seat test pressure, if specified in the PO, shall be equal to the pressure rating. There shall be no leakage during the test. On valves intended for low differential pressure service or vacuum service, a low pressure air test or air seat test shall be carried out by the manufacturer, so specified in purchase order. A test pressure shall then be specified by the purchaser and witnessed by the purchaser representative. If so desired, the pressure shall be applied as globe valve under the disc. Check valve, the test is not required. Gate plug and the ball valve successively to each side of the closed valve. For valve designed for flow in one direction only and so marked on the valve, pressure shall be applied on the upstream side of the valve only. Heat test. In case of the valve shall be in the closed position with the side not under pressure open to atmosphere for detection of leakage. For front valves in the double block and bleed application and for the valves with independent double seating, pressure shall be applied inside the bonnet or body with the disc closed and the both sides open for inspection. So plug and ball valves shall be operated from fully closed to fully open position 3 times to demonstrate satisfactory mechanical operation and continued tightness after operation. It is permitted to charge sealant before testing on the valves, relying on sealing compound to effect the seal. Then hydrostatic seat test. Because till now we were doing air test. So seat test shall be made with seat clean and free of oil. However, if necessary to prevent galling, the seat may be coated with film or oil or of viscosity not greater than that of the kerosene. This requirement does not apply to the valve in which the lubricant provides primary seal. The seat test shall be carried out by closing the valve in the normal manner. Valve shall be subjected to hydrotest pressure at gauge pressure and not at less than 110% and 38 degrees rounded off to higher 1 bar increment. This shall be applied as specified in the seat test. There shall be no visible leakage during the test. For check valves, the hydrostatic heat pressure shall be applied on the downstream side. In addition to this, the check valve shall also be tested in the downstream side to 25% of the hydrotest pressure. So also no leakage is allowed. What about the low pressure closure test and high pressure closure test? So special test, fire safe tests. When required, specified in the relevant Indian standard, these tests shall be carried out and agreed procedure requirement between the manufacturer and the purchaser. Anti-static device testing. So when required and specified in the relevant Indian standard, these shall be carried out to an agreed procedure and a requirement between the manufacturer and the purchaser. Test gauges. The gauge used for pressure test shall be calibrated at intervals not exceeding 3 months by an independent competent authority. If the manufacturer does not have the facility, results shall be recorded and shall be liable to inspection and verification of the purchaser representative for acceptance as when required. So in all the pressure tests, pressure shall be measured for stated duration without continuous use of input to pressure buildup by mechanical or other means. So you should not be pressurizing it while it is under pressure, holding the pressure. And there are some reference standards to observe like API 598, IS 6157, and nothing not the less Google Assistant as well. So let me know if you like this small presentation on valves only, and in any details if I missed or any language, if you need it in Hindi or any other language, do let me know. And for such exciting, knowledgeable content, please subscribe to our channel and like all our videos. Thank you very much.